right, example 10.7 part 2. Now what we've done is we have established that as this bullet and bob system rises upwards to a certain angle, it gains potential energy due to gravity. You know that when you raise anything up against gravity, you put potential energy into it, and we found out that the potential energy due to gravity was, I just lost it right here, 2.93 joules. 2.93 joules of potential energy as this went up. We care about that because the potential energy gained can be transferred into the kinetic energy, or the change in kinetic energy going upwards, and that can be turned into a final velocity and ultimately an initial velocity of the bullet, which is what we want to find. Okay, so our goal for part 2 right here, we're at step 2, and actually we're working backwards, as you recall. That was part 1. This is going to be part 3. Our goal for part 2 is to find out what the velocity was of this bullet and bob system right before it starts rising upwards, as that pendulum arcs upwards. Okay, so this right here is going to be our goal, to find out the velocity. And again, we get that velocity from knowing the kinetic energy of it, and we know the kinetic energy from knowing the potential energy. So let's go ahead and start this. We remember, hopefully, using conservation of energy, that any change in potential energy is going to result in an opposite change in kinetic energy. Here's what I mean. That should be an equal sign there. That's, whoops, that's pretty bad. Oh, for Pete's sake. Delta U equals, sorry about that, negative delta K. So if you increase potential energy, you're decreasing kinetic energy. Or as you know, if you drop something, it's increasing kinetic energy by falling downwards, but it's decreasing potential energy. So we have a kind of a negative relationship right here. So we can write this like this. That is our UG, which we know, our potential energy due to gravity, is going to be equal to a negative. Whenever we see a delta, that means final minus initial, right? Okay, but since it's negative, well, that flips the sign, so it's really like saying that our potential energy is going to be equal to K initial minus K final. So we care about this in K initial right here, because what's the K final up here? What's the final kinetic energy at the top where this comes to a stop? Well, to a stop, that means there's no kinetic energy. So our final kinetic energy is going to be 0. We know that. And so really our kinetic energy, as this bullet and bob system starts swinging upwards, is going to be equal to our potential energy, which we just found. So our kinetic energy, initial, as it barely starts swinging upwards, is going to be also 2.93 joules of energy. Now again, for the sake of this problem, we're assuming a few things. We're assuming there's no mass in this rod right here, or we can ignore the mass. And we're assuming there's no friction or anything. But in an idealized system, that would be the case. This the kinetic energy, sorry, that it would have going into start swinging would be completely lost and completely turned into potential energy as it got to the top of that arc right there. So this is our kinetic energy of the bullet and bob system as it starts swinging upwards. Well, what we ultimately care about in this part 2, is finding the velocity. Because after all, we could really break this, well, we have been breaking it into at least 2 different parts right here. But the velocity of the bullet and bob system going into that arc is going to be the velocity of the two masses together. So let's find the velocity of the bullet and bob system. So I'm going to just draw it here again. So that's the pendulum rod, and here's a bullet inside the bob right there. And the kinetic energy just before it starts swinging upwards is going to be, we said, 2.93 joules. So the velocity is what? Well, let's call this, I'll just call it velocity for now, and I'll mention how to give it a subscript later. Well, we can find the velocity. We don't know it quite just yet, but we do know that the kinetic energy of any object is 1/2 mv squared. And so to solve for velocity, that means the velocity that system must have must be the square root of, looks like 2k, or 2 times the kinetic energy, over m. 2k over m. We should be able to solve then for the velocity of this system. What do we have here? Oh, that would be, I've got a little bit of lag here in my screen recording. 2 times our kinetic energy, which is 2.93 joules, divided by our m. Okay, what's our m? What's our mass? Well, like before, our mass is going to be 1.5 kilograms plus 0.05 kilograms. So that would be 1.55 kilograms, because after all, we're adding the mass and the bullet and the bob together. So that's the mass we're going to divide by, 1.55 kilograms. And that should give us a velocity of what? 1.94 meters per second. Let's put a nice dotted box around that. Velocity is 1.94 meters per second. Okay. Now the reason I didn't put a subscript on here is because I need to clarify something. I'm going to write in black over here. We know we have a velocity here and a velocity here. Well, we know this velocity is 0 because it comes to a stop. And this we just found is 1.94 meters per second. Okay, and so we would tend to want to say, okay, this is VI and this is V final, which is fine for this part. But if we compare it to the first part, we have a VI of both objects over here, the bullet and the bob. And then once they hit, we have this V final after they've connected, and we have the conservation of momentum that we can solve for. Well, my point here is that the V final in the first part is the same thing as the VI in the second part. So the final velocity after these two objects connect is this velocity as the bullet and bob system starts to arc upwards. So we essentially just found this final velocity of the bullet and bob system after they connect or after they collide, because we found the initial velocity of the bullet and bob system as it starts to arc upwards. So let's simply just call it VF. Okay, V final. I'll put a 1 there. V final for part 1. It's really you could say it's V initial for the second part right here. That's 2 and this is 1, but this is going to be the V final after the bullet and bob have connected. In fact, you know what? I shouldn't have just dotted that. I'll just draw a box around it. V final, and if you want to write after collision, if that helps. I know that's kind of bulky, but V final after collision, that's 1.94 meters per second. Let's definitely put a box around that. That was our goal for this video, to find this final velocity after they collided. And then in our final video, in part 3, we're going to use conservation of momentum. Now knowing what this velocity of the ball and bob system are after they collided, we can use conservation of momentum to find out what the initial velocity of the ball or bullet is, and that's what we're ultimately trying to find. So that's it, and I'll see you on the final and next video.